Okay, so we want to construct a graph of this function. And you're doing quite well, but we want to make sure we understand the process. Okay, well, when you construct a graph of a quadratic function, I'll give you a specific set of steps. Okay. Find the x-intercepts if they exist. Find the y-intercept. Find the axis of symmetry. Find the vertex. Of course, you can do step 5 as you go, which you find the x-intercept, you put the points on the x-axis. And the assignment for today mostly asks you to graph by clicking on one of the x-intercepts. And then a couple of other steps, okay? Most of you didn't get to do that. Most of you didn't get that done, and I strongly recommend you do, because it gives you a big head start when you take pre-calculus, okay? I mean, this occurs, about 3 weeks into the course. So if you understand everything we've done, and you all have been doing really well, understand everything that we've done, you're going to have a big head start in pre-calculus, and you're going to be really grateful for it, okay? So please get this assignment done, even if it's late, for your own sake. Make sure you understand this process, because it will certainly appear on the exam. Okay. So what do? Well, we find the x-intercepts. Your x-intercepts occur when y is 0. Okay. Y is this. Y equals 0 when this is 0. Okay. If I have the numbers corrected, you can check me. Okay. So use the quadratic formula. You're going to get negative. Negative of negative 18, which is 18, plus or minus the square of negative 18, minus 4 times 3 times negative 7. Okay. Now, I've been telling people wrong about this. So correct what I might have told you. Your discriminant, somebody had 240 for the discriminant. That looked good. Okay. But if you did, you missed the negative sign on the negative 7. The negative 4AC would be negative 4 times 3 times negative 7. 2 negatives give you a positive. You're going to get a plus 84. You see your discriminant. Okay, excuse me. Somebody is telling me I've done something boneheaded, I think, which is not uncommon. Okay, the bonehead thing I did, and thank you, is I have the plus 7 here, copied it down as a negative. I'm going to use lack of peripheral vision due to this mask is my excuse. but really there's no excuse. Okay, short-term memory. Okay, so yeah, that gives you a 240 for your discriminant. Square root of 240 is about 18.7, I think. So you're going to have, well, it's going to work out to where you get either about negative 0.1 or 0.2, or about 6 point. Something like that, something pretty close. Okay. Now, I don't have room to graph here. So let me put this information on a graph. And the zeros that will zeros are x equals negative 0.1, x equals 6.1. So we plot these points. Negative 0.10 is here. We'll say 6.10 is maybe about here. Okay, understand that step? It's very straightforward. You just use a quadratic formula to find when y is 0. Okay. Now, I say if they exist because for some equations, your discriminant could be negative. You'd have a square root of a negative, so there would not be any x-intercepts. Now we know that the graph is going to be a parabola. It's either going to be shaped like this or like this. It can easily have this shape and be above the x-axis, so it never goes through the x-axis. And if that happens, then you're not going to have zeros. Not real zeros. You're not going to have zeros that you can plot on the graph. So sometimes they don't exist and you have to go to the other steps. You won't have zeros to plot. And well, we find the y-intercept. Y-intercept happens when x equals 0. So y equals f of 0. In other words, you plug 0 in for x, right? Because we're writing f of 0 now. That means x is now 0. And that equals 3 times 0 squared minus 18 times 0 plus 7, which equals 7. Okay, so now we've got this information. So we put that on our graph. So maybe we better not do that just yet, because we don't know what the vertex is going to be. Okay, so if we put 7 here and find out the vertex is at 483, we're stuck. Excuse me. So we don't know the extent of this graph. We don't know where its vertex is going to be. So we're going to wait a minute to plot this information. we found the equation. We found the location of the y-intercept. We just don't know where to put it on the graph until we know what scale we need to use for the graph. Okay, well, the axis of symmetry. It's at x equals negative b over 2a. And I'll emphasize how you can see that in the quadratic formula. Here's the quadratic formula. You have 0 at negative b plus this, divided by 2a, and at negative b minus the square root, divided by 2a. Halfway between those zeros, you have negative b over 2a. Right there. If you understand that, is an easy way to remember the axis of symmetry. Well, negative b over 2a in this case would be negative 18. Sorry, the negative of negative 18 over 6, which is 3. And now we can safely draw the axis of symmetry because that's not going to, that's just a vertical line. It's not going to affect our scale. So now we can say, okay, x equals 3. Here. And of course, at every point on this vertical line. Now, the graph is a parabola. It has to go through this point and this point, and it has to go through the axis of symmetry. There's something wrong here. Because there's got to be something wrong with my calculation of the zeros, because I'm going to get a contradiction. So obviously I made a mistake. I'm not sure where it is. It's a square root of 200. Oh, heck. Square root of 240, 340 is about 18.7. Okay. Square root of 240 is about 15.5. Okay. So, having made a mistake, we have to get rid of my picture because I've already got a y-axis in there. Easy enough to redraw it. While I'm at it. Remember this too. Well, okay. This is going to be better. We'll get this fixed in a minute. One. And this is okay. When x is about 0.5 or 5.5. Again, that's just a straightforward application of the quadratic formula. That's more. Y is 0 when this is 0. If you use a quadratic formula, don't do a stupid estimate wrong. You get this. Now, how did I figure that out? Well, I figured this out by doing my arithmetic more correctly. Okay. So now when I draw the graph, if x is 0.5 here, let's say it's about 5.5. Okay. Not quite to scale. This should be a little closer to the origin, and this should be a little further out. But we have them 0.50 and 5.50. The thing that troubled me was that the y-intercept should be 7. And the way I had it drawn, this point to the left of the y-axis, y-intercept is going to have to be, turns out it's going to have to be negative. Okay. So now here's our line. X equals 3. Everywhere on this line, X is equal to 3. This is our axis of symmetry. Now we want to find the vertex, because we, step 4, sorry, we find the vertex. Okay. Well, a vertex is on the axis of symmetry. The x coordinate is 3. Then y equals f of 3. Just indicating, if we use the f of x notation, that x is going to have to be 3. So f of 3, we plug in 3 for x. We get 3 times 3 squared minus 18 times 3 plus 7. Well, 3 times 3 squared, 3 squared is 9, 3 times 9 is 27. Add 7, we get 34. Then we have minus 18 times 3, which is 54. So it's going to be 34 minus 54. Which is negative 20. So the vertex at 3, negative 20. And that will go to our graph. You say, okay, vertex is going to be 3, negative 20. We can put that anywhere we want. Since I labeled the x equals 3 here, I'm going to scratch it in here. Okay, so here's where y is negative 20. Now we can graph our y-intercept, which is at 7. Okay, this is negative 20. That up here is 20. So here's 10. And about here is 0.07 y-intercept. Now, does it make sense we could draw a parabola through all these points? Pretty good to me. Okay, so go ahead and draw a parabola. Okay. There's our graph. Label the vertex. Which is this point. Maybe my arrow place give myself a little more room. Okay, does that make sense? That's the process. If you follow that with the process mechanically, it's always going to work. And if you do several problems of this nature, then it'll seep into your brain. And when you encounter it in pre-calculus, it'll be there for you. Maybe a little vague because you're going to forget things. Okay, but it's going to be there. It's going to come back to you. And there's a process. Now, another thing about this is the minimum value. X5 equals F3 equals negative 20. This function can't go below negative 20, but it does at negative 20. And this is handy. So, just to summarize, the zeros over here. Step 2, Y-intercept. Write it like this. Think about what this notation is telling you. 3, axis of symmetry. X equals negative b over 2a. Which is 4. It's this way. Vertex is 3f of 3. 3 negative 20. There's our graph. Notice we get the minimum value. Because there are a lot of functions you want to get a maximum minimum value. Going to see one. We throw a ball upward. Its position is a quadratic function. If you graph it, you see how high it goes. Okay. Interesting thing. Sideline. How many play baseball ever? You know that baseball involves 9 guys in the field. Somebody pitches the ball, somebody hits the ball, right? How many know what a curveball is? Okay. Well, I might as well not tell you, but I will anyway. If you hit a fastball, the ball's coming faster than it is with a curveball. So you would think when you hit it, it's going to travel further. However, with the curveball, the ball is spinning. So when you hit it, the spin causes it to rise faster and stays up in the air longer. So it's easier to hit a home run off a curveball than a fastball. Very interesting. In my freshman physics instructor, who became dean of a major technological university, did a lot of neat stuff and just died last year. He was a pretty young guy. Played a lot of sports. He's still playing basketball in his mid-30s. Those younger people, except he's too good to play with me. Okay. Kind of a neat guy. And I was thinking that in connection with my great nephew, kind of a star travel league player. He's a pitcher, but he also hits pretty well. Anyhow, that's apparently beside the point. since I started talking about it, I've finished. Okay. Okay. This camera just always really wants to see a picture of that aardvark, apparently, because it just isn't focusing. The aardvark stops working. I don't know what I'm going to do. Okay, come on. Okay. Now that looks pretty good. So I'll walk closer to my screen. See if it's really legible. Okay, there we go. Okay, we sell 500 minus X widgets if the price is X. Cost of widgets is 20,000. Understood. This is in dollars and this is in dollars. Okay. So price maximizes profit. Maximizes profit. Okay. What's the revenue? What is the profit? And then graph the profit function, find the maximum. Going on. Okay. What's the revenue? That's the amount of money when all these things are sold, right? Profit. You got to subtract the cost. So there's a couple of definitions. It should maybe jog your memory. If not, we'll drop some more hints. We'll give you a couple minutes to work on this. Okay. When I say the cost of the widgets is 20,000, that's what I, as the seller, have to pay to get the widgets. Okay. I'm going to say this is the cost. Oh. And you got to pay $20,000 to get widgets to sell. Okay. So that's not the revenue. Okay. To get the profit, you got to first figure out what the revenue is, then subtract the cost, what you have to pay to get the widgets. Using the bookstore as an example, but use that with Colton. Okay. So if we sell widgets, or say they're selling books, $50 books, which is a pretty good bargain, the price of textbooks. If they're selling books for $50, then they're going to sell 500 minus 50 of them, right? Be 450 books. So how much money would they get? Well, they sell them for $50. You sell 450 books for $50. Okay. You take in $22,500, I believe. Okay. But it costs them $20,000 to get the books, right? So they only have a profit of $22,500 minus $20,000, right? $2,500. I'm not going to write all that out, but just to give you a picture. So we have somebody selling something for some price X. This is how many they're going to sell. Because the higher the price, the fewer they're going to sell. So if they're selling for $500, they're not going to make a thing. Because they're not going to sell any. Nobody's going to pay $500. 500 minus X is 0. If X is 500. Okay. And here's again what they have to pay. Now, if the price is X, what's the revenue? What's the profit? And then we want to graph that profit. Okay, so 1. To get how much money you take in, you want to multiply the price by how many you sell. Okay, what's the price? X. How many do you sell? 500 minus X. Okay. So, some of you got that. You guys think through it. It's not a trivial idea. Okay. Some of you didn't get it. Of course, we talked about it last time, but again, there's a lot going on right now. Okay, so there we have it. So we could call that R of X, the revenue. Now that's really a pretty easy idea to understand if you think in terms of numbers. When you start thinking in terms of X, well, it's a different level of abstraction. Okay. So we're going to generally want to call that R of X. General notation. The profit is revenue minus cost. And that equals there's your revenue, that's your revenue function, right? Let me write that. And that equals R of X minus 20,000, right? Okay, but of course we know what R of X is. X times 500 minus X, and then we subtract the 20,000. So P of X equals X times 500 minus X minus 20,000. Now, this is a quadratic function. Because you're going to have an x times your negative x. You're going to have a negative x squared here, right? Okay. So we simplify this. This is quadratic. Vertex will tell you your maximum. Okay. Now, I want to go on and talk about domain and range. Because this is something else. We'll give you a huge head start in the pre-calculus class. Okay. One of the first things you see, and if you start the class out, okay, here's an analogy. Say you've had surgery, and it's kind of painful, so much that you really want to take some medicine for the pain. Okay. What they tell you, if you've ever had surgery, you would know this. It's painful, and not all surgeries are painful. You know, I had coronary bypass surgery. And the ribs were sore. A little hard to take a deep breath. Kind of hard to even take a shallow breath, but you can still breathe. You just didn't breathe deep, and it didn't hurt. Okay, there's really no pain other than sore ribs, which went away. So you go through some major surgeries without a whole lot of pain. On the other hand, relatively minor surgeries like hernia surgery, you kind of want pain now. Okay, it's a pretty minor procedure, but it hurts. I've not had it. People have done it. Actually, I did when I was too young. Anyhow, okay, what they tell you, I'm telling you this is kind of immediate, is don't wait until you're in a lot of pain to ask for pain. Get ahead of the pain. Okay? Because if the pain gets ahead of you, pain meds are not going to help you that much. Okay? So what I'm telling you here is get a good start in your pre-calculus course by understanding domain and range and the other stuff we've done in this course, and you've done a very good job of it. Okay? Get ahead of the pain in pre-calculus by doing the best you can here. Okay? It's for your own sake. Anyhow, so we're going to talk about domain and range. And let's see if this is focused. So we want to talk about domain. Range. And let's focus. Okay. Again, talk about domain and range. Basic idea. And there's an assignment due tomorrow. Okay. Anywhere to get that. Again, you get ahead of the pain in pre-calculus by knowing some of these things when you start, so it doesn't overwhelm you right at the beginning. Major set of all X values. The major set of all Y values. Now, I haven't written out all possible conditions and all the words that would go with the definition, you can read that. This is, I'm not understanding. Let me just sketch that. The function. Okay. There it is. Now I guess I ought to put a scale on it. Any scale I want on it. Let's just say this is -6, and this is 5. Right. No, I don't think that's 7. And up here, this is, let's say, 100. And of course, -100, you know where that's going to be down here. As far down as this one moves up. Okay. Now the set of all x values. Right here's an x value. Corresponds to this function, right? Right here's an x value. And the function's nice and continuous from here over to here. So here's a picture of your domain. It's all the x values in green. Your range, set of all your y values. So you have a y value up here. And you have a y value down here. Here's your range. Specify your domain. You want to write it as an interval or as an inequality. So the domain can be expressed by an inequality. In a little more time, I'd ask you to do estimates. But think, what do you think the x value is here? What do you think the x value is here? Okay, that might be -5, right? Looks a little, maybe -5.2, but we'll just estimate -5. Okay. Over here, we'll estimate 7. Say, okay. So there's an inequality. X is between -5 and 7. What about the range? Well, see, if that's -100, that looks not quite how. I'm going to say about -40 there, and about 130 up here. Does that sound look about right in terms of the scale? Okay. Now we can write this in interval notation. There's -5, 7. It's the interval notation assigned. In the range, -40, 130. This means all the numbers from -5 to 7, including -5 because of the closed bracket, and 7 because of the closed bracket in this one. Similarly, here, every y value from -40 to 130. Well, that'll take you a long ways in the assignment. You have probably at least half a dozen graphs that ask you to specify what the domain and range are. And some of them are a little more complicated than this, but you're going to have plenty of support from Open Math to figure these out. Okay? So it's be a really good thing for you to do. Plus, probably going to have something about domain and range on the exam. Fair enough?